Hello everyone. This is how I love geometry. I'm Mr. Cao. This problem is from 2012 Aime1, problem number 13. Three concentric circles have radii 3, 4, and 5. An equilateral triangle with one vertex on each circle has side length s. The largest possible area of the triangle can be written as a plus b over c times square root of d. Let us find a plus b plus c plus d. Okay, I will draw a scratch graph. So all of them, three concentric. Then the second one, okay, it's not beautiful, but we can understand. So, and three vertex on each circle, equilateral triangle. So it let us to find largest possible. So how many cases? One, I think. One case it will be like this way, right? Okay. One. Yeah. Yeah, three vertex on the circle, on each circle, right? On each circle. That's one possible. Another possible also, yeah, we can imagine it can be like one is here, another is here. So, yeah. Of course, the second case will be the largest. Only two possibles, right? So, it means now problem it convert to let us to guard the area of, so because we know this is equilateral triangle and the side, each side is s, and obviously if this is, that's the center of the three circles, so it means this is 3, right? If this is 4 and this is 5, so now problem convert to like there is a equilateral triangle and there is a point inside. Let me draw another graph, right? Like, yeah, maybe like this way. 3, 4, and 5, right? Yeah, 3, 4, and 5, and each side we know they're congruent, right? Each side is length is s. Now let us to find the area of this equilateral triangle. So when we saw this, there is a point. Let me say this is point is O. Inside an equilateral triangle in a square or in a isosceles right triangle regularly, we want to make the problem easier, and we will rotate. When we rotate, we want to make to gathering all of this given information into quadrilateral, into regularly, into a triangle, then to make the problem becomes easier. Here we will use the same way to do this. So let us say A, B, C, here is O, And let us, if we say this angle is alpha, then we can rotate this 60 degree, this AO around it, A 60 degree, so this, let us say, so you see, and O prime, this is O prime, O prime A also 3, right? I just rotate, and of course this angle, well, alpha, because this angle here, this is beta, alpha plus beta 60 degree. If I rotate 60 degree, and this angle will be alpha. Now let us connect the O prime and B. Now we will find these two triangles will be congruent. Which one? The original OAC. Now this side and this side, that's S, right? And the angle alpha, SA, and AB, and here is AC. They are congruent, and SAS. So these two triangles will be congruent, right? And according to this one, this side will be full. And rotate, if we connect O prime and O, now this triangle AO prime will be a equilateral triangle, because AO equals AO prime, right? All of them are 3, and this angle is 60 degrees. So when I connect them, this triangle will be also equilateral triangle. This equilateral triangle, and it means O prime and O equals 3. So this is 3. Now we can easily to find this is a triangle. BO prime O is a right triangle, right? 3, 4, 5. So 3, 4, 5. Now how to find this S? I mean, we want to find AB, right? If we got AB equals S, and the area of ABC will be squared, right? So now it will becomes clear, because we can use cosine law. This is 3, this is 5, and this angle now we know is 60 degree. If we know the angle of this, or we can calculate the angle, the cosine angle AOB, then we can find the S squared, right? Now this angle is 2 parts, right? And this angle, let me say cos theta, I mean angle O prime OB equals theta. Then we can got, now we will use the formula cosine theta plus 60 degree, right? This angle, we want to get angle AOB, the cosine value of this angle. And this is, we know the formula, cosine theta times cosine 60 degree minus sine theta times sine 60 degree, right? So we just want to get this 2. This 2 is easy. This is a right triangle. We know this is 4, and this is 3, and this is 5, and this is angle theta. So cosine theta is how much? Cosine theta is 3/5, times cosine 60 degree equals sine 30 degree. So minus sine theta is 4/5 times sine theta, right? So we got 10. Here is 3 minus 4 times square root of 3. Okay, now we will find sine squared, right? Sine squared equals according to the cosine law, and it will equals 3 squared plus 5 squared minus 2 times 3 times 5, and times this one is 10 over 3 minus 4 square root of 3, and here, and we know 2 and 5, and so 9 plus 25, 9 plus 25 is 34. So we will minus, here is 3 minus 9, oh, and minus 9, and the negative plus 12 square root of 3. Okay, so finally we will got the area. What we want to know, the area ABC equals, this is 25, right? 25 plus 12 square root of 3. So equals, so it will be 4, here is 25 square root of 3 plus, and this is 4, so here is 3, right? 3 times the square root of 3, so finally equals is 9 plus 25 over 4 square root. So ABCD is a, so equals finally answer plus 25 plus 4 plus 3, so that's 34, 38, 41, right? That's the final answer. So done, we got it. So all of this, we just use a special way. This special way, we use it not just normally, not in the regular study geometry. We can meet this special way in the math competition. And they just rotate. I just introduced when you got an equilateral triangle, square, and isosceles right triangle, there is a point inside. This is the way, if you rotate something, and you will gathering the given information in a triangle, and it will make the problem easily to solve. Okay, hope you enjoy it. Thank you.